All right, let's look at the homework 7.4, problem number 7. All right, so let's use partial fractions to evaluate this integral. All right, so I'm going to write down the integrand. So you have x squared minus 16x minus 1 and over. We have a repeated linear term, so x minus 1 squared. And then we have x squared plus 1, right? Then we know that this can be decomposed into, right? So we have to have x minus 1, so it's a linear factor. And then we have a repeated one, so we have x minus 1 quantity squared. Then we have a quadratic one. So you have x squared plus 1. Right? So linear term, you have a on the constant on top. Repeated linear term, so you have another constant. Right? This is a quadratic term, so it's going to be a cx plus d. Right? Then this can be, just to put them back together. So we have x minus 1 squared, x squared plus 1, right? Then you have, you multiply a by, we need to multiply by, so we need another x minus 1. And we need another, we need x squared plus 1 as well, right? Then b, we need just x squared plus 1, right? And then you have a cx plus d. And then this is going to be x minus 1 squared. All right, so let's compare the numerators, and I guess we have to multiply these all out. So first I'm going to multiply this guy out. All right, so we have x cubed. X times 1 is plus x. Negative 1 times x squared would be negative x squared. Then negative 1 times 1 would be negative 1. Right, then let's see, then multiply this guy out right here. So this is going to be x squared minus 2x plus 1. Right, so let's write that down. All right, so I'm going to let's see, multiply all out. So you have a times x cubed. And I'm going to write minus ax squared. So I took care of a times this guy and a times negative x squared. So you have a times x. So that would be ax plus ax. And then we have the last one here, negative 1. So it's going to be negative a. Right? Then distribute b, so you're going to have bx squared plus b, so bx squared plus b, right? So that took care of those guys, and of course that one, and that took care of that. All right, then you have cx distributed plus cx cubed minus 2c x squared. Right, and then plus cx. Right, so we distributed this guy to all three terms. Right, then I'm gonna have to distribute d to all three terms. Right, so we're gonna do d, so plus dx squared minus 2dx plus d, and this is equal to the the original numerator, which is x squared minus 16x minus 1. Right? So I'm going to collect the like terms, and I'm just going to look at the coefficients. So let's look at the coefficients of x cubed. Right? So what are they? So first we need, so we have a x cubed, and another cube would be cx cubed, and that's it. So you have a plus c is the coefficient of x cubed. And since the right hand side does not have x cubed, so the coefficient must be 0. Right? So let's look at the x squared term. Right? So x squared term would be, here's a negative ax squared and positive bx squared, and there's a negative 2cx squared, and there's a dx squared. Right? So we can add, let's see, coefficient is negative a plus b and minus 2c plus d. And this is going to be equal to, coefficient of x squared on the right is 1. So this is 1. Right? Then let's look at the x term. So x term is ax and cx and 2dx. Right? So we have, so x term would be, so a plus c minus 2d is equal to, right, x term is a negative 16, so that negative 16. Right? Then lastly, this is the constant term. So we're going to have a constant term. Let's see, there's a there, negative a, and a positive b and a positive d. Right? So we have a negative a plus b and a plus d. Right? And this is equal to negative 1. Right? Then let's solve for a, b, c, and d. Right? So I'm going to use these two equations. So this guy and that guy. Right? I'm going to do a subtraction. Negative a minus a cancel out, b minus b cancel out, negative 2c minus 0 is the negative 2c. Right? D minus d cancel out, and then we have a 1 minus negative 1, so it's 2. Right? So by dividing through by negative 2, we get c equals negative 1. Right? So once you know that, we can plug it in here. So it's a plus negative 1, so a minus 1 equals c. So by adding 1, we have a equals 1. Right? Once you know a equal a and c value, we can plug those guys in to find out. Let's see, a is 1, c is negative 1, and then you have negative 2d is equal to negative 16. Right? So the negative 1 cancel out, and then you can just divide through by negative 2 to get d is equal to 8. Right? So we have a value and a c value and the d value. So we just have to find the b value. Right? So we can probably use the, let's see, last equation here. Right? So we have, right, a is 1, so it's negative 1. B is, we don't know, so we have b plus b. And d is 8, so it's a plus 8. Right? So this is equal to negative 1. Right, by subtracting 1 from both sides, we can cancel this, and this is going to be 0. So by subtracting 8, we have a b is equal to -8, right? So we found this value, right? So let's rewrite the original integral this way. Right, so you have an integral, right? Then let's see, a is 1, so it's going to be 1 over x minus 1, right? And b is -8, so it's going to be minus 8 over, or actually, I'm going to write it this way. How about this? -8. And a 1 over x minus 1 squared would be, I'm going to write it as quantity x minus 1 to the -2 power. All right, then c is -1. So here we have a negative. C is 1 -1, so it's a x over x squared plus 1. All right, last one is d, so it's going to be plus, I'm going to write 8 in front, then you have a 1 over x squared plus 1 with respect to x. All right, then I'm going to just do a little bit of an adjustment here. So since I want to do a g prime g of x format over g of x format, derivative of x squared plus 1 is 2x. So I would like to have 2 here. So multiply by 2 and divide by 2. Right? So we'll get this. Right? Right? Antiderivative 1 over x minus 1 is natural log of absolute value of x minus 1. Right? Derivative, -8. Antiderivative, this guy would be add 1 to the power. So you have x minus 1 to the -1, and divide by -1, so they'll be positive. Actually, I'm going to write this guy as a fraction form. So this is going to be 8 over x minus 1. So this is 8 over x minus 1. Right? And then here you have a -1/2, and then you have a natural log of, we don't need absolute value in this case because x squared plus 1 is always positive, and plus 8 times, this is going to be an arctangent of x, and then you have a plus some constant c. Right? That's it. All right, so let's type it in. So we have natural log of absolute value of x minus 1. Right, then we have a plus 8 over x minus 1, a minus 1/2 natural log of x squared plus 1, and plus, actually it's going to be minus 8. Was it minus? Let's see, let's go back. It's actually plus, sorry. So this is a plus arctangent, arctangent of x plus some constant c. Right? Let's submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.